MS Ramaya University of Applied Sciences.
Hello students. Let us discuss design and construct BCD to XS3 code converter. Aim of the experiment is to design and construct a BCD to XS3 code converter. The availability of a large variety of codes for the same discrete elements of information results in the use of different codes by different digital systems. It is sometimes necessary to use the output of one system as the input to another. A conversion circuit must be inserted between the two systems if each uses different code for the same information. Thus, a code converter is a circuit that makes the two systems compatible even though each uses a different binary code. BCD is an abbreviation for binary coded decimal. Binary codes for decimal digits require a minimum of 4 bits. The BCD code expresses each digit in a decimal number by its nibble equivalent. Weights are assigned to binary bits according to their positions. The weights in the BCD codes are 8, 4, 2 and 1. The logic diagram of BCD to XS3 code converter is as shown here. The K-maps of BCD to XS3 code converter are shown here. The apparatus required for this experiment are trainer kit, connecting probes, IC 7432, 7408, 7404 and 7486. Procedure for verification of BCD to XS3 code converter functionality. Determine required number of inputs and outputs from the specifications. Derive the truth table for each of the outputs based on their relationships to the input. Simplify the Boolean functions for each output as a function of its inputs. Draw a logic diagram that represents the implementation of the design. Check all the components for their working. Insert the appropriate IC into the IC base. Make connections as shown in the circuit diagram. Verify the truth table and observe the outputs. Conclusion. A BCD to XS3 code converter is designed using corresponding truth table and its functionality is tested experimentally.
Hi students, name of the experiment is Design and Construct BCD to XS3 converter. Aim of the experiment is to design, construct and verify the functions of BCD to XS3 converters. The operators required for this experiments are digital IC trainer kit on which we are going to perform the experiment. So here you can see on the top of the digital IC trainer kit, you can see the knobs here. So 10 are in a red color, 10 are in a black color. So these are the output knobs. So here the bottom you can see the 10 black color knobs. Here we are going to connect the inputs, and inputs can be varied by varying the toggle switches which are present here. So if you keep the toggle switch to the top position, that means the input is high, and if you keep it to the low position, that means the input is low. So output can be verified by looking into the LEDs. If the LEDs are on, that means that particular output is high. If LED is off, that means the particular output is off. And here also you can see there are 4 IC bases, so where you can place the ICs. Each IC base has a IC slot, so where you can place a IC. So here each IC base consists of 16 slots. So and also there are 16 pins at the left side of the IC base as well as the right side of the IC base. Total 16 pins are there. So these are internally connected to the each slot, and also each IC base consists of VCC and ground. So VCC and ground are used to give the power supply to the IC connected here, and at the bottom you can see there is the clock signals of various frequency 1 Hz, 10 Hz, 100 Hz, 1 kHz and 10 kilohertz. And at the right side you can see there are two yellow color knobs which are used to check the conductivity of the patch cords. So if we can connect the patch cord here, and you can see if the LED bulb is on and if the beep noise is coming, that means the patch cord is working properly, otherwise the patch cord has some problem. ICs. So these are the 4 ICs which we are using to construct the given logic diagram. So one is OR gate, the second one is AND gate, third one is NOT gate, and the fourth one is 3 input AND gate. And the name of the ICs are, this is 7432, this is 7408, 7404 and 7411, and patch cords. These are the patch cords we are using to connect the logic diagram. So before using any patch cord to connect the given logic diagram, we have to check the continuity test for each patch cord. Take the patch cord, turn on the power supply to the digital IC trainer kit. It is turned on now. Now place the patch cord between the continuity tester knobs, and you can see there is a LED on and there is a beep noise. So this means the patch cord is working fine, and similarly we have to check continuity test for all the patch cords which we are using for the experiment. Now we will place the ICs into the IC base. First I am taking NOT gate 7404, and before placing the IC into the IC base, make sure the IC has a notch that should be always upward direction. So I am taking it and I am placing into the first IC base. After placing it, close the lever, make sure the IC is not coming out. Similarly, we have to take other IC, that is 7432 OR gate. I am going to place it and I am closing the lever. Similarly, AND gate 7408, third IC base. After placing, close the lever. And lastly, I can take one more IC. It is also AND gate. It has 3 input. It is a 3 input AND gate 7411. After placing it, close the lever. Make sure the IC is not coming out. Now let us start the connecting the circuit based on the logic diagram. Now let us start connecting the circuit as per the logic diagram. Before connecting the circuit, I will connect all VCC and grounds for every IC base. There are 4 IC bases. We are using all 4. So pin number 14 is VCC, pin number 7 is ground. So in every IC base you can see the last 2 slots are left free, since we are using only 14 pin ICs. So therefore the last 2 slots are not connected. So pin number 8 and pin number 9 are not in use. So after pin number 7 we have to consider pin number 10 as pin number 8, then 9 and so on till pin number 14. So now similarly I am going to connect VCC and ground for the second IC base. So now after connecting VCC and ground, let us start connecting from each IC. So first I will finish off all the connections regarding the NOT gate so that no confusion will be there. Then I will move on to OR gate, then I will move to AND gate, then I will move to 3 input AND gate. So coming to the first IC base, pin number 1 of the first IC base is connected to input B. So input knobs are here, so I can connect anywhere. I am connecting here as B input. There are 4 inputs A, B, C, D. So B input I have connected to pin number 1. Pin number 2 of the NOT gate is connected to pin number 5 of the AND gate, that is here. Pin number 3 of NOT gate is connected to another input, that is C here. Pin number 4 of the NOT gate is connected to pin number 1 of the 3 input AND gate here. Pin number 4 of the same NOT gate is also connected to pin number 9 of the 2 input AND gate here. Then pin number 5 of the NOT gate is connected to the other input D. Pin number 6 of the NOT gate is connected to pin number 2 of the 3 input AND gate here. Pin number 6 of the NOT gate is also connected to pin number 10 of the AND gate, and it is also connected as the same pin number 6 is also connected as output directly, that is Z output. There are 4 outputs, W, X, Y, Z. So I have connected one output here. So this completes all the connections regarding the NOT gate. Now we will move on to the OR gate here. So now first OR gate, pin number 1 of the OR gate represents the input A. So that is I am connecting here. So all the 4 inputs are connected, A, B, C, D. So now pin number 2 of the OR gate is connected to pin number 3 of the 2 input NAND gate. Pin number 3 of the OR gate is connected as one output, that is W. Here I can connect. Next, pin number 4 of the OR gate is connected as input C. So this is A, B, C. So I am going to connect it here. Pin number 5 of the OR gate is connected as input D. So this is input D. I am connecting here. Pin number 6 of the OR gate is connected to pin number 9 of the OR gate, that is here. Then pin number 10 of the OR gate is connected to pin number 12 of 3 input AND gate. Pin number 8 of the OR gate is connected as the output X. After W I will connect X. Pin number 11 of the OR gate is also connected as output, that is Y output. So all the 4 outputs are connected, W, X, Y, Z. Pin number 12 of the OR gate is connected to pin number 8 of the AND gate, 2 input AND gate, that is here. Pin number 13 of the OR gate is connected to pin number 11 of the AND gate. So now this completes all the connections. So regarding OR gate, now we will move on to the AND gate, 2 input AND gate. So now here pin number 1 of the first AND gate, 2 input AND gate is connected to input B. So I am connecting here input B. Pin number 2 of the AND gate is connected to pin number 6 of the OR gate, that is here. Next, pin number 4 of the AND gate is connected to pin number 6 of the OR gate again. Pin number 5 of the AND gate is connected to pin number 2 of the NOT gate. This is pin number 6 is connected to 9 of the OR gate. So 9 is here. I am shorting it. Next, pin number 8 is connected to 12 of the OR gate. It is already connected. And pin number 13 of the OR gate, AND gate, the pin number 13 of the AND gate is connected to the D input again. I am connecting it here. Pin number 12 is connected to C input. I am connecting it here to the C input. Pin number 11 should be connected to pin number 13. It is already connected. So now we have completed the connections of third IC base, that is 2 input AND gate, and coming to the 3 input AND gate, that we have already done the connections. It has a 3 inputs, pin number 1, pin number 2 and pin number 13. 13 should be here, and this is pin number 12 is output. It is connected to 10 of the OR gate and it is connected here. So this completes the circuit connections. Now let us verify the truth table of BCD to XS3 converter. So in order to do that, we need to turn on the power supply first. Now you can see the LED bulb is on, the power is on. So now all the inputs, that is A, B, C, D, all the inputs are at logic low. So when all the inputs are at logic low, the output is 0, 0, 1, 1. You can see here, this is true according to the truth table. For the next combination of the input, that is 0, 0, 0, 1, I'll make the last input D1. So output you can see 0, 1, 0, 0. Similarly, so for the next combination of the input, that is 0, 0, 1, 0, third input I am making high, and you can see the output is 0, 1, 0, 1. So the next combination I will make 0, 0, 1, 1. So 1, 1 I have made 0, 0, 1, 1. So you can see the output is 0, 1, 1, 0. And similarly I will go for the next combination, that is 0, 1, 0, 0. You can see the output is 0, 1, 1. Now next combination 0, 1, 0, 1. So you can see the output is 1, 0, 0, 0. So next combination is 0, 1, 1, 0. You can see the output combination is 1, 0, 0, 1. The next combination is 0, 1, 1 and 1, and you can see the output is 1, 0, 1, 0. Now next combination is 8, that is 1, 0, 0, 0. So now you can see the output is 1, 0, 1, 1. The last combination is 1, 0, 0 and 1, and you can see the output is 1, 1, 0, 0. So this verifies the BCD to XS3 converter, and this completes the experiment.
At MSR UAS, we spark your imagination unlike any other.